You talked about four technologies, industrial electrode boilers, air source high temperature heat pumps, industrial ovens, and dryers. But there are some other technologies one reads about a lot. For example, advanced thermal batteries. How did you pick some within the scope and eliminate others?
It's a wonderful question, Susan. And with any analysis, of course, you have to choose what's in and what's out. So the reason we chose those four technologies is because they are gaining market share. They have pilot programs, especially for ovens and dryers and electrode boilers. These are proven technologies that have low risk. So we wanted to focus on technologies that were fairly low risk today, that already have some level of policy support, where we're seeing a lot of adoption. Because one barrier for electrifying industry is that, if you have a well-designed plant with really tight engineering, you're reluctant to put in a new technology that perhaps isn't proven, right? It's called the first mover problem. So
Right.
that informed how we selected our technologies. And thermal batteries, it's a wonderful technology. It's in its early stages. It really could have an impact, but we were laser focused on how can we move the needle today to start reducing carbon, because we know we're going to need a lot more of those advanced technologies in the future to get to net zero.
Excellent. Your analysis really focused on the US, and yet our audience here is basically globally representative from Asia, from Europe, from Africa, and from Latin America. To what extent do you think that your conclusions in terms of the cost, in terms of the co-benefits, in terms of the investment required, and effectively also in terms of the policy recommendations you're making, to what extent do you think those will hold true in other markets?
I think, thanks, Susan. That's a great question. And I'm really appreciative that people from all around the world are attending. I think our general findings are transferable to any location in the world. And what do I mean by that? So we've modeled the typical plant configurations. Of course, they might change here and there around the world, but we make ethylene and fluid milk and other products that we looked at in more or less the same ways. So I think the technological opportunity is transferable, no doubt. The amount of emissions that one saves will depend on the fuel that's being burned, of course. So there might be unique factors to these replacements that would affect the overall energy and emissions balance. But by electrifying, you generally save energy and you reduce emissions as long as your grid is relatively clean. Now, if it's in a place in the world where the grid is very reliant on coal or high emissions, then it might take longer and maybe the balance will look a little bit different. In terms of costs, we try to use sort of internationally average, capital costs and installation costs, but of course costs will vary, labor rates will vary. But I do think the high level findings that these technologies work, that they can reduce energy and emissions in many circumstances, and that in general they can be cost effective under the right conditions, and that policy report will be required for other conditions like high spark gaps. Those are transferable, and they allow other adopters to know what they need to deal with and what needs to be optimized in order to make it successful in Ghana, in China, in Bozeman, Montana.
Fantastic. One of the drivers of I love that term, the spark gap, right? I've never heard that before. So, but I totally get it. One of the drivers of that spark gap, though, in the US at least, is this huge surge of unprecedented demand for electricity, driven by the hyperscalers, as they're called in the US. Um, to what extent is this flipping this over or electrifying low and medium heat exacerbate that issue and actually would increase the size of the spark gap? And what do you see as the role of this? Is this just going to make the existing problem, comparing this to natural gas, worse, or is this going to actually help drive electrification?
Oh boy, that's a great question and a tough one. So just for everyone's context, the US is seeing a real data center boom. We have more data centers than any other country on the planet, and there are huge investments for AI computing, which are starting to really strain our electricity grid. And so when we talk about adding industrial electricity loads on top of that, I
Hmm.
understand, Susan, why there could be some concern. And in fact, this is a barrier. In talking to industrial plant managers and equipment manufacturers, getting enough electricity to the plant can be a barrier for electrifying. However, this is something that policymakers need to be aware of. So in places where we have net zero goals, in places where we have goals for reducing local pollution and addressing climate change, we do need to electrify industry. And so the numbers that we produce and the policy recommendations we produce need to be taken on board, but in the context of those other loads as well. I will say that there's kind of a new shift that's happening in the data center space, which is because these data centers in the US can't connect to the grid quickly enough, they're installing their own power on-site power generation, which has the effect of potentially relieving grid stress. And if they're producing more electricity on site than they need, which some of them may do, they can export, which might open up the opportunity space for industry. But we've got to look at all of those
Oh,
loads together. And now at least we have some information to do so in the US.